Have you ever hard-coded a secret in your source code and then checked it in? If not in your application code, maybe a build script, Docker file, or configuration file? If you have, your application security team may come knocking on your door soon. Let's look at the issues of secrets in code and what a pain they are to resolve. In our example, I've created a new repo in Bitbucket and I've cloned it locally on my workstation. Let's create a new file with VI called buildfile.sh. This would presumably be used to run a job in the pipeline or do some other kind of work that we don't need to specify in this example. In the code, let's add a statement, password equals, and assign a genuine looking password. You may not think this is realistic, but I see things like this all the time in the code that I review. Let's save that file with a right quit. And let's run git add dot. This will add the changes I just made in the current directory to the staging area. And let's commit the changes by running git commit -m and in quotes a message of first commit. To save the staged changes to the local git repo. And finally, let's push the commits to the remote repo with git push -u origin master. Let's bring Bitbucket back up and do a refresh of the page. We see our new buildfile.sh is there. If we click on it, we see the file contains the hard-coded secret, in this case our password. Let's assume some time goes by now and someone from the appsec team runs a tool and finds out what we did. Let's see if we're able to fix the problem. We'll go back to our code. We see our build file is still there. The first thought most people will have will be to fix the code by getting rid of the need for the secret in the code. This can be done by retrieving the secret from an external source. We'll make a very simple change to our code. Again, we're assuming this is a bash script, and we'll read our secret from the command line. Let's open up our file again with VI. And to fix it, we'll set our password equal to the value of $1, assuming we read it as the first parameter from the command line when we run the script. By the way, we're not pretending to write production quality code here, just illustrating how to handle secrets. Getting secrets from the command line can also be problematic, but at least we're getting the secret out of our code. Let's right quit and save the changes. If we display the contents of the file with cat, we see our changes there. All we need to do now is check in our code and life is good. Let's run git add dot, then git commit -m. Our comment will be fixed secret. And finally, let's push this to the remote repository with git push -m origin master. Let's go back to Bitbucket once again. Clicking on our project name of my project, we'll refresh the page. Now let's see what's in the buildfile.sh file. If we view it, we see our change was pushed with the new code and the secret is gone. Awesome. We're heroes. Everybody gets a raise. Now we can go back to doing important things, right? Yeah, not so fast. Let's take a look at the commit history for this project. The entries go from most recent to oldest, top to bottom. Let's select the original entry at the bottom. Uh-oh, there's our secret. It's still in the history of commits for this project. Git-based systems like Bitbucket maintain a history of commits for branching, merging, rolling back, collaboration, as well as other reasons. Although it's possible to delete the history, it's a very destructive process and not something to be taken lightly. Most Git admins will not let you make such a drastic change just to fix issues like this. Good secrets detection tools, as well as good hackers, will find secrets in history. So when you think you've cleaned up the problems, they're still there. Let's go back to our working files and look at other ways we can look at our commit history. If we run the command get log -- graph, and the file name buildfile.sh, we see our graph of the commits for this file. Each entry includes the commit ID hash, the author, the date, and the comments. If we run the command git show, and the first 7 characters of the hash for the initial commit, we see all the metadata about the commit, but the most important thing we see is the diff between the code commits. Notice we see our password in plain text. There are other ways to see the history too. If we run get show, the shortened version of the hash, a colon, and the file name, buildfile.sh, we see the previous contents of the file when the password was still present. We can even go back and see all the previous code by running the command git checkout in the hash of the commit we're interested in. This changes our working directory to the state of the code for this particular commit. Now our code is as it was before we made our change. If we simply cat the buildfile.sh, we can see the secret in our code just as it was. Imagine a hacker found this on a public site where your code was posted, or even an insider who had malicious intent in your organization. If they know what they're doing, they could easily find these issues. So what to do? Updating the code to remove the secret is not enough. Even updating the code so it no longer needs to use the hard-coded secret is still not enough. The secret must also be revoked. To revoke a secret means to disable it, remove it, change it, and then not reintroduce the secret back into the source code once the secret's been revoked. How you revoke it will be different based on the system it connects to. Many tools will have a UI like we see here with Bitbucket. Clicking the revoke link, we start the process of removing the old token. Of course, you won't be able to see the token when you revoke it, so it's not always possible to know for certain the hard-coded token in your application is the same as the one you're revoking. The best advice is, when in doubt, revoke. After the tokens are revoked, you can generate new tokens, but be careful about protecting them, especially if you have them showing on a YouTube video. The same goes for passwords, private keys, and other secret material. Change it and don't reintroduce it into your application. If you enjoyed this video, please like, subscribe, and share. Thanks for watching, and remember to always begin secure.